Hello and welcome to the OCR Further Maths videos for Pure Core. This is Calculus 5, Volumes of Revolution and Mean of a Function, and this is 5.2, Rotation about the x-axis. So as we discussed at the end of the last video, what we're looking at here is starting with our curve here, f of x, and in this case rotating that curve 360 degrees around the x-axis. When we do that, a solid is formed, and what we want to do is to be able to find the volume of this solid. We do this in a really similar way to how we do the area under a curve for integration, and it's by finding the volumes of cylinders rather than the areas of rectangles. Okay, we're going to have a little look at this in GeoGebra. So here you can see on the left, this is our curve, and here it is over here as well. Now, if we look at just a single cylinder here from the rotation, we can see it looks like that. If we want to find the volume, we're going to need to do a cylinder, repeated cylinders, and then sum those volumes. So here we can see a number of cylinders. Now as we start with a large dx, we would have a small number of cylinders, and as dx tends to 0, you can see we have far more cylinders, and you can see that the approximation of the volume becomes closer and closer to the actual volume. Okay, so now what we're going to do is look at finding the volume of revolution. Here what we're looking at is the region between this curve f of x and the x-axis, and these 2 points A and B on the x-axis is rotated 360 degrees around the x-axis to give this solid. Okay, so when we look at this solid, we can see that this distance here, this y, is actually the radius of the cylinder. And dx here, that small increase in x, is the height of the cylinder. So the volume of this individual cylinder is pi y squared delta x. And similarly to finding the area under a curve, what we want to do to find the volume of the entire solid is to sum up these small volumes between A and B. So the volume is approximately equal to pi y squared delta x, because that's the volume of those cylinders. So the volume of the solid of revolution is given by the limit as delta x tends to 0 between x is A and B, the sum of pi y squared delta x, and so that is this integral here between A and B of pi y squared dx. Okay, so we're going to look at an example now. We're going to find the volume of the solid formed when the curve y equals x cubed is rotated 360 degrees around the x-axis between x equals 2 and x equals 3. So in this particular example, we have A is 2, B is 3, and y is x cubed. So if we use this formula, we're going to integrate between 2 and 3. Take the pi outside, it's usually easiest. We often leave the volumes of revolution in terms of pi. Y squared, so we've got x cubed squared dx. So that volume is given by the integral between 2 and 3 of x to the power 6 dx. So that is x to the 7 over 7 between 2 and 3. So we end up with our final volume being 2059 over 7 pi. Okay, in the next video we're going to do 5.3 rotation about the y-axis.